All right, what's going on, Internet? So in my previous video, I talked about the fact that in a lot of the big conferences, the prominent ones where we have a lot of AI startups that are actually getting traction with users, one of the primary themes of discussion right now is evaluations. So evals for their models. And it doesn't seem sexy and it doesn't seem super interesting, but it's critical for actually scaling an AI product to ensure that it responds to the user in a consistent way that's reliable and meets their needs of what they want. And many of these AI startups and AI companies, when you get to a certain size, you need to actually start automating the evaluation of the model itself. So that's when we actually create a thing called an LLM as a judge or an AI judge, where we have AI critiquing and judging other AI on its output. So it's kind of like AI all the way down. And today, what I want to do is I want to walk you through how some of the best AI companies today are incorporating these LLM as judges inside of their overall pipeline to ensure that their product is as good as it can be for the users that are using it. All right, so before we get started, I want to give a really big shout out to Hamel. So Hamel wrote this long post on LLM as judges, and I'm going to kind of walk you through this, a distillation of this from my understanding and also applying some of my own lessons learned from the experience that I've worked with companies as well. And I'm going to walk you through this at a high level. We're not going to necessarily go through the blog itself. We will, as always, go through slides to walk you through some visuals associated to the piece and some main takeaways you should grasp. So the first thing we'll talk about here isn't necessarily LLM as judges to start, because before you get to LLM as judges, you need to make sure you have a good eval framework in place. So I highly recommend you watch the previous video, and if you won't do that, I'm going to give you a TLDR of that video right now. So this kind of graph here summarizes the experience a lot of AI products go through when they're trying to build and scale those products. So on one axis, we have evals, the importance of these, and oh crap, we need this. And then on the other side is the fanciness of the AI that we're applying. Now, at the beginning, like most of us, we like to vibe with ChatGPT and we're happy with that. Then we create some clever system prompts. After that, we start to build interesting demos, and we then start to show those demos to different users. And then finally, we get to the point where we actually have to really deal with production. We have to scale this up to users. And as we go through this process, you can see that people start to care a lot about evals, and they start to realize how important and real evals are. And the question is, why are evals important? Well, when your AI responds in inconsistent ways, it's really hard for us to know why it's either degrading in its responses or what within one of the steps in a large chain is happening. Because oftentimes these AI products, they have multiple steps in a chain, right? And it's kind of a black box to most of us. And that kind of goes to our next point here. So if we're looking at this black box here, so say this entire thing is our AI product, right? So this is our AI app. AI app. And in here, we can't really see into it because the only thing that we see at is the end, right? The end, we see the output. In the beginning, we see the user's input. But if our product does more than just respond to people, if it goes off and takes action, such as scheduling meetings or booking tickets or doing whatever else, there's a lot of stuff that happens in between. And if we can't see into it, we can't necessarily see which one of these points is the largest point of error that we need to fix. And that's really where evals come into place. We need to put in infrastructure so we can actually see into this black box and critique and fix the certain points inside of this chain to improve the reliability of our AI product. And that's what evals do for us. And it also gives us the opportunity to focus on the 80-20. Because in the end, there might be multiple stops or multiple steps that are failing, but in those steps that are failing, maybe only 2 and 7 are the ones that are causing most of the errors. And if those are causing most of the errors, that means that we can actually fix those. And if we fix those, we get an 80% improvement with 20% of our effort. That's the whole 80-20. So this is a really important piece of understanding the importance of evals and why you need to use them. One other thing I want to call out before we get to judges is that when you're doing evals, when you're setting up your process and your infrastructure, you want to focus on binary evaluations. Because oftentimes when you look at eval frameworks, they're going to look something like this, where you have a kind of a gradient scale. So we have gradient scale. We have 1, 2, 3, 4, and then kind of as you keep going up. And then you have different categories. So you have helpfulness, tone, accuracy, truthfulness, etc. And these eval frameworks are off the shelf. And that's why a lot of people tend to use them or rely on them, because you can take it off the shelf, you can repurpose it for your use case and move on. You don't want to create your own custom evals. And that's a big error. And that's a big issue that a lot of companies I see run into. And the reason that's an error and a big issue is that oftentimes, how do you know what's the difference between a 3 and a 4? Or maybe a 2 and a 5? How do you know if something is improved, and if it has, what's the objective difference between those two categories? It's a very subjective thing when you look at when it's on a spectrum. And it's hard to actually take action from something that's so subjective. Instead, what the best AI companies do is they focus on binary. evals. So they ask themselves, is this a pass fail, true or false, yes or no, one or zero? And you can really distill down many different types of things that you want to improve to a binary question. A lot of people say that they can't. You can. I promise you, I've done it a million times. You can distill it down to a binary question. I'm just giving you common examples here to start with. So say that we have a RAG application. So you're asking questions of documentation inside of your company. There's a few examples. So is the answer correct? Is it objectively correct based off the question? Yes, no. Another one you can ask is it relevant to the question? So relevance can sit on the spectrum. So how relevant is it? But really the question here is it pass fail? So is it relevant enough to answer the question effectively? So that's a pass fail question. And that's one of the other big things I wanted to touch on before we get to judges. So we've talked through the importance of evals and setting up the process beforehand. So I recommend putting in a process infrastructure first before you move on to automating it. Because if you don't have this in place, you're going to automate something that's incorrect and wrong, and you're going to waste a lot of time. So if we cut that out of the way, next, LLM judges, what are they? So when you do evaluations, you start with human experts, right? So we have our human expert here, that's our judge. And this expert is going to look at the different types of steps inside of our application and see, okay, how is the AI doing throughout this process based off of the binary evaluations we set up previously. And it's going to judge it based off of good or bad. And when it judges it, it's going to give it a verdict. So it'll say, you know, pass, fail, or yes or no. And then in addition to that, it's going to give a reason or a critique. So it's going to say, okay, it's a pass for, you know, reason A. And you'll give maybe 2 to 3 sentences as to why it's good or bad. Once we've done this a few times, we'll have a database or kind of a data set of different kind of judgments of what's good or not. We then can kind of templatize this and put this into another LLM. So we can then pass off the judgment to an AI. So this AI starts judging this AI. And like I said, it's AI all the way down. And that can actually allow us to scale this. So we can have this AI monitor all the different interactions over time and create a large data set of what's going wrong or right, and then improve that over time and iterate. So we can scale this with the application and the number of interactions our users are having, because then we can't have the human looking at everything because it's a bottleneck and takes too long. But we can have an AI do that. So that's kind of the reason why we use LLM as judges and the benefit associated to it. Okay, so at a high level, what is the process that we're going to walk through today? So the first step we're going to do is we're going to get an expert. So we need to find an expert to do the judging initially. Then we're going to generate some data, and that data is going to be generated either from AI synthetically or from users. And I'll talk more about that later. Then we'll have our expert do the judging. Once they've done the judging, we can build the LLM based off of these judgments. So that's going to feed into this next step. And then after that, we're going to review our LLM's judgments and then iterate and improve on it. And we'll keep on going back and forth like this until the LLM judge is as close as it can be to the expert over time. So those are our steps. So the first step here, we need to get an expert. So this is a really important first step, and it's something that we shouldn't necessarily think that we as developers or builders think that we're experts. So if we are, that's good, but most of the time we're not. So we need to get somebody in that knows what good looks like when it comes to the response from our AI product. So that could be a lawyer, that could be an accountant, that could be a doctor, some sort of physician, or some sort of expert in the space that can spend time reviewing our data sets. There's a few things I want to mention on this point here is that why would we want experts in the first place? What's the benefit for us? So the first one is that when we have somebody in that's an expert, they really help us understand what good looks like. Because like I said, in the end, we're not the experts, so they know what good looks like when it comes to a response from AI if it's specializing in a certain space. In addition to that, they're actually up-leveling the bar of good. Because oftentimes when you work with an expert, they have a high bar for what they expect from an AI. So that increases the quality of the AI product over time. It might take more effort, more kind of time to do that. But when they set a high bar, that means our end users get a higher end product. And then another really important part is that a lot of these SMEs, so in their heads, these SMEs, they tend to have a lot of nuance and kind of subtleties associated to what is good and how do you actually break down the actions and or answers that good looks like. And some of these subtleties are subconscious or unspoken. But if we force these SMEs or ask them politely to judge our output from our AI product, the really important thing here is in addition to the verdict, once they give their verdict, and then the more important part is the reason, when they give the reason, they start to tease out the nuances associated to what is good. Because oftentimes when you talk to an expert, they say, oh, well, a lot of this stuff is kind of like, wishy-washy or intuitive or subjective or whatever else. But when you put them through this process and you really test them out, they start to pull out and tease out what those reasons are and those nuances are. And we can then bake that into our LLM Judge in the future and also our AR product over time. So when having them reason things, their verdicts, we can get higher end products and we can pull out those nuances. And then lastly, is when we get these SMEs involved, we then have buy-in, right? So if you get a SME and you get them involved, and you get them involved early, they're more likely to buy in and approve of the final end product because they were so heavily involved in building it. So that's getting the expert. Next is generating the data. And before we generate the data, we want to understand the dimensions or shapes of the data. So what do I mean by dimension or shape? Well, each data set, there's different types of categories of ways that our users can interact with our application. And I have a little cube here to kind of give you an idea. So we have one side, another side, and then another side. So this is just an example, just different categories that can exist. So one is a persona. One is a feature, and the other one is a scenario. So these are different categories or shapes or angles that our users and our user interactions can be assessed and reviewed. And so what does this actually look like? Well, we have a simple table here. This could be a lot bigger. And like I said, these categories are not static. They can change. But just as an example, we have features. So say in our AI application, one part is email summary. So it summarizes email. That's one feature. Another one is it schedules meetings on our behalf. So those are features, examples of features. So for personas, we could have new users. We could have expert users. We might even have elderly users. And all of these personas have different ways of interacting with the product. And then finally are the scenarios of with the product of how it interacts and responds. So one is the user could ask for one item that has multiple matches. That's a scenario we'd have to deal with. Another one is they'd asked of something of the AI that has no match when it responds. And there's a variety of other things. So these are different areas or situations that our AI can get into based off of the user they're interacting with and the associated feature that they're calling. So these are kind of shapes of the data set that we need to understand when we're structuring our evaluations and we're baking that into our end AI. So I have some examples here from Hamel's blog of what these kind of generated prompts can look like. Because like I said in the beginning, actually, let me go back for a second. What I said in the beginning is we can generate this data either through humans or AI. So we have the option of generating data from AI or our users, which are humans, hopefully. And with this, it's ideal to take a subset of the data from existing users if you have them. So if you're building an AI product and you already have users that are using it, you can take a subset of that data set and ensure that that data set fits the overall shape of the data you're looking at. So of the different items that we mentioned here for these different shapes of the data, you want to ensure that you're filling that in as much as possible with existing user data. But that's not always going to be ideal or situational because sometimes your users won't interact with it in ways that you can think up. So then in that case, you use another AI to create synthetic data. So this is when they generate data to fill in these gaps of what these scenarios and features would look like. And that's what this table down here shows, is that synthetic data generation. So I'm going to zoom in so you can see it. Hopefully you can see it. And we have a few things. So we have a feature, our scenario, and a persona that we discussed previously. And here are just some examples. So in this case, we have a feature that's order tracking. The scenario, we have an invalid data that's being provided. And there's a frustrated customer. So this is the prompt that we're going to give to the AI to then create the synthetic data of that scenario. So if we look through this, it's asking it to generate a user input for someone who is clearly irritated and impatient, using short, terse language, etc., etc. And then they're asking for the status of their order. So they're asking for this specific order number of their status, or the status of the order number. And then the assumption here is that the order number actually does not exist. So when the AI responds, how is it going to effectively respond to this type of persona and this type of scenario? So when it generates that data, we can feed that into our overall table above. Another example here, let's say we have a new user that's asking for a search of a new contact, but in the ask that they give, there's actually multiple matches found in the scenario. So here we have the prompt that we're going to feed into the AI that's then going to create the synthetic data of the scenario. So we're asking, so create a user input from someone who seems unfamiliar, so this is the new user piece of the system, and using hesitant language, and then they ask for a person named Alex. But the assumption here is that there are multiple contacts in there that are called Alex. So how does the AI respond effectively in a situation like this? So these are the synthetic data sets that we're going to create that we're going to then add to our overall table so we can start doing evaluations on it based off of our AI's response. So just to recap, how does this process work in total? So first we generate data, right? So that's either going to be from AI or humans. Once we've done that, humans, I can't spell humans, perfect. Humans, all right. Once we've done that, we're going to feed that data into our AI app to get the responses out because we've synthetically generated the scenario. We're going to get the response out of our AI based off of each one of those scenarios. We're going to capture those responses. And when we capture these, if you watch my previous video, you know that the eval infrastructure that we've set up previously is going to be able to capture these conversations. And those things are called traces, and you can set those up through different tools like Phoenix and Brain Trust and Humane and a bunch of others. And so once we've done that, we've captured these. We're going to then organize them in a table. And this table is likely going to be something simple for our SME to use. So our expert that's doing the judging, we need to make sure there's zero friction for them to use this and judge the interactions. So it's either a very simple UI that they can switch through conversations and make judgments, or it's going to simply be in an Excel sheet because a lot of experts know how to use Excel. So we can put all this stuff in Excel as well. So that's the overall process of the generating data, moving on to the judging period. Okay, so now we come on to the judgment piece. And the judgment here is saying, okay, we have our human expert. They're going to judge the output from our AI, give the verdict and the reason. So here we have an example that I want to show you from Hamel's blog, where we have our user and then our AI response. So our user here is asking to book a table at an Italian restaurant. And then our AI is responding with the response of, okay, 7 p.m. at this restaurant, etc., etc. So this is a pass because they responded and did what they said. But there's an important piece here that I want to highlight. So in this reasoning of the pass, so they said it passed, and here's the critique or the reason as to why it passed, is this is good because it worked out, it confirmed the number, it booked the table, etc. But you can see the point here, however. It could have asked the user for seating preferences, dietary restrictions, and other types of things. So even though it passed, there's areas that could be improved. And that's exactly why we add reasoning and critiques, even to items that passed, not just failed. Because we want to improve the AI's response for all different use cases and scenarios. Because we can improve the AI's ability to ask for these types of items and improve the interaction with the user. So that's one example of a pass. And then we have one example of a fail. All right, let's zoom in here. Hopefully you can see this. So we have our user and our AI, and our user is asking, I can't log into the account. It seems like the password's incorrect. Okay, so the AI response says, okay, please reset your password, forgot your password. So that is a fail based off of the interaction we're expecting. And then we have a reason as to why it failed. Okay, so it says AI provided generic solutions without acknowledging the user's frustration, checking for other issues in linked account, etc., etc. So the primary thing here is that it failed to offer empathetic support and additional assistance. Instead of simply saying to reset their password, you should ask these questions like, are you locked out? If you're locked out, maybe we can do something instead of resetting your password. Or maybe we can do something in relation to maybe your IP is located somewhere else. So maybe you should use a VPN or something else like that. So you should have the AI be more empathetic and try to understand the issue before actually just giving a solution. And that's why this failed. And we have a very specific reason as to why it failed through the reasoning. So we can add that to our future judge as well as AI product. Okay, and a few last things I want to mention here. So I've already mentioned this, but when you're giving your judge the conversations, you want to use something that's very simple. And Excel is simple. Everybody knows how to use Excel. So we're going to use something that's simple that they can utilize. Or a dashboard, a UI, whatever you want to do there. Next is when your expert is in giving their reasons or critiques to the AI based off of their verdict, you should give them a tip of saying, okay, write this in a way that a new employee would understand. So don't use jargon, terminology, or don't be too terse, because oftentimes with experts, when they're giving their judgments, they tend to be very short sometimes, and you want them to give enough information so the AI can learn from those reasons. So write it as if a new employee could understand it. And then last, I thought about this, and I think, there are some companies that are remote first, and those remote first companies that tend to do a lot of asymmetric communication through text and other things, they tend to adopt a culture of low context culture. And those low context cultures tend to assume that the other person that's receiving this message has low context. So I'm going to give them as much context as possible so they understand what's happening. And people that work at organizations like this, from my experience, they tend to be better expert judges of scenarios, so they tend to get better AI products in the end, based off the judgments they've made. So just an observation I made, but an interesting thing nonetheless. All right, so we have our expert judge, they've done their judgments, and we have our data set now. So we have the AI response, and we have the judgment of that from our human. That's where we are currently. So next is we want to start building out our system prompt for our LLM Judge based off of that data set. And to do that, we have kind of a structure for the system prompt, and I'm actually going to walk you through an example from Hamel's blog. And in this structure, we're going to start with a role or task. So that's going to be what is the role of the LLM and what's the task associated. We're going to give them additional context to the judgment if there is context. Sometimes there is, sometimes there isn't. And then we're going to have some guidelines to how they should judge and considerations they should have before they do anything. And then last, and also pretty importantly, is we're going to give them examples, because in the end, this judgment is going to be based off of a few-shot learning situation. We're going to give them evaluations from the human, because remember, above, our human just did a bunch of judgments. We want to take both the verdict and the critique or reasoning. We're going to bundle that into our system prompt of our LLM Judge. So it judges like the human would. So this is a really important piece that we're going to add. All right. Now, follow me. So we're going to go to this here. Hopefully it works. So this is our system prompt for the example. So in the system prompt, you can see at the very top here, we have the task and role. So we're basically saying you're an evaluator for this honeycomb query language. So in this example, we're basically creating a judge for a query language to see if the translation from English to the query language was effective. That's kind of the goal here. So we're going from English to query language. Was it good or bad? See here, we're basically giving a role and then saying the task is to ensure that actually can judge the query based off of the input, is it good or not? And then making sure that the LLM understands that it understands the nuance of this honeycomb query language. So that's our starter point. Next, we have the additional context. So this is the context that I mentioned previously. So we're going to give them some information about the query language itself, so they do understand how it works and how it's structured. After that, we're going to have the guidelines. And remember that there's different types of guidelines that we can have. And there's a lot of information we can put inside this section. A few examples that we could input is to analyze the response carefully. So make sure that you analyze the question that's being asked to the AI. Also, we want to make sure that it analyzes it through the specific lens of the context we've given it above here. So this information around the query language, make sure you look through the lens of being an expert in this language. Another item is giving a binary decision. So saying pass, fail, or yes or no is what we want from it. And also what we want from it is the reason. So the reason or critique of the binary verdict. So we're giving it some guidelines as what we expect from this specific response from the judge. And then next we have the actual examples. So this is the few shot that I mentioned earlier. That's quite important when it comes to ensuring that it judges like the human does. And in this, they're doing it all through XML tags. So if you've watched any of my previous videos, you probably know that I've talked the importance of using delimiters. So that's what these XML tags are considered. So when you create a system prompt and you're prompting an AI, usually if you have delimiters, the AI understands the sections of the system prompt and it can kind of discern the difference between the front of the intro, the evaluation examples, etc. So it's basically a way for the AI to segment the system prompt into different sections. So in here, you can see that examples. Example one, so they first have the question, right? So this is the question that came from the user. After that, we have the AI's breakdown of that. So this is the AI applying its understanding of the query language itself, saying, okay, this is the breakdown of the trace ID, the calculation count, filters, etc. So once we have that, we have the critique. So this is the reason as to why it's given it a verdict of good. So it gives it the critique and the outcome. And then we have the same thing in other examples. So these are all from the human that we had earlier judging stuff. And we're going to apply that here. So we have another question. We have the breakdown of the query. Then we have the critique itself, the verdict. And then this keeps on continuing over and over and over. And the number of items you would include in your few shot example would depend on the model's context window. So if you have a large context window, you could probably put a lot of few shot examples. And if you don't, you might actually adopt a kind of advanced method of this I'll explain later on. But in the meantime, just know that you can probably put in 5 to 10 to 15 depending on the context window, and also depending on the size of the critique and the type of questions that you're sharing. So I'll quickly share it here. I don't have a visual for it, but I'll make it really short. So the mention that I made earlier is that with the context window, if it's not as big as you'd like and you would like to put different examples in for different questions, there's this concept of, I think it's called in-context learning or something like that, where you can actually take that example section. So let me go up here to show you. So this, let's do different color. So this section here, the examples, you can actually swap that out in real time. So as your LLM Judge is assessing the response from an AI, based off of the question from the user, you can actually take that question, run it through kind of a database to say, okay, what's the type of question that's being asked? So maybe you have a question that's being asked in relation to dogs. You're like, okay, I know that this AI answers questions about dogs, ice cream, and forests. So let's say dogs, ice cream, and forests. Oh, that's enough. Forest. Okay. So if a question comes in with dogs, I'm gonna actually go to the database for dogs. So we'll have our database here. We're going to pull out few shot examples from previous human judges and then shove that into our system prompt in somewhat real time. So when the judge gets the answer and the response, they can then have a better assessment of that question in an iterative fashion. So it's an adaptable prompt that changes over time. So this prompt here is basically changing iteratively over time. That's one of the points I wanted to make around the advanced setup here. But also don't worry about, don't worry about that too much because this is more of an advanced thing. You just want to get your LLM Judge built out first, and then you can move on to that next. Okay, so in the end, we have a few things. So we have our judge built out, our LLM Judge. We have our critiques from our human. And now we want to do one last thing, which is evaluating the judge's responses. And this is considered error analysis. It's a fancy word of saying looking at your data. And we're going to spot check certain things. So maybe you have 1,000 conversations. And of those 1,000, you're going to take out maybe 50 that are diverse enough to cover the shape that I talked about earlier. So the shape of the cube. We're going to make sure that we have the shape of the data perfectly with that sample we pulled out. We want to assess how close is the AI's judgment to the human's judgment. That's what we're trying to achieve with this next process. So what you're looking at here is a few things. So this this item here, so this section, the first one, model response, this is the response from the AI. So this is the answer to the question that was asked from the user. Here we have the LLM Judge's critique. So this is the reason as to why they verdicted as a no in the outcome column. Then we have the human's critique and the other items here. But before we get to that, this here, this section on this side over here, is what we have coming in. And when we share this with our human, they're actually going to judge the judge of how they performed. So they're going to assess the judgment from the LLM. So they're going to fill in the rest of this information based off of what they can see. So in this situation, we have a guy named Philip, and he's judging their critique from our AI. And he says, okay, based off of what I can see that this is also a bad item, so the judge is correct. And this is my additional reasoning as to why I think that's the case. Then, in this case, the human also writes a new query that improves upon the first. And then a really important part here is, I don't know if you can see it. Hopefully I can move my head out of the way. You can see there's an item here called true. And in this column, we're actually looking for agreement. And the agreement column is basically something that we're going to track over time. And we're going to gather a bunch of these judgments of the judge. So it's very meta. We have the human judging the judge. We're going to gather, was it in alignment or not? True or false? And the reason we're going to do that is because we want to do something like this with this visual, where we have the judge for the AI and we have the human judge. And what we want to do is over time, as we aggregate these judgments of the AI from the human, we're going to update its system prompt with these insights from that review process. We're not going to do it all the time, but we're going to do it maybe once a week or once a month or once a big change happens to the AI product. We're going to add that in. And the reason we're going to do that is we're going to try to push this AI's judgment as close as possible to the human judgment. And the goal is to basically to get them to be aligned with the human's judgment so it's as effective and as good as a human would be at scale. With that being said, internet, that's the concept I wanted to share with you today. So I hope you found this informational, entertaining, exciting. If you did, please reshare it with your friends. And also, if you would like assistance from my consulting company, I help companies automate internal processes with AI. It's called Gradient Labs. So if you'd like a free 15-minute discovery call, you can check out the link below. We can have a conversation to see if there's a good fit. I appreciate your time, and I'll see you next time.